There is a machine wrapped around your life right now. You can't see it, but it powers the device you're watching this on. It powers your home, your city, hospitals, airports, water systems. It powers everything, yet most people never stop to think about how it actually works. It stretches across continents. It moves electricity at the speed of light, and without it, the world would fall apart. It is the power grid, the largest machine humanity has ever built. But the grid isn't just the infrastructure, it's the nervous system of modern civilization. And when it fails, the whole body suffers. In this video, we'll break down exactly how the grid works, why it's more fragile than most people realize, and how the next decade could reshape energy forever. Welcome to NextPhase. Electricity is unlike anything else we consume. We can store water, we can store food, but electricity, for the most part, it has to be used the moment it's generated. That makes electricity the most demanding product on Earth. Every second, grid operators balance supply and demand with incredible precision. If demand exceeds supply, frequency drops. If supply exceeds demand, frequency rises. Too much deviation, and sensitive equipment shuts down. In worst case scenario, this can cause entire power plants disconnecting to prevent catastrophe. To put this in perspective, it's like you're juggling flaming chainsaws. Only instead of burning your hands, you might accidentally black out an airport. So no pressure. Electricity is generated in many ways. Coal plants, nuclear stations, gas turbines, hydroelectric dams, and wind farms. Once electricity is generated, you might think to yourself, what happens then? Well, welcome in step-up transformers, increasing voltage to 100,000 of volts. Higher voltage allows power to travel long distance with minimal loss. Kinda like your phone battery, if it wasn't an absolute embarrassment to technology. Transmission lines are hooked onto pylons, the steel towers cutting across landscapes, carrying this energy across entire countries. As electricity approaches cities, step-down transformers are introduced, reducing the voltage in stages. First, to 132,000 volts for regional areas, then to 33,000 volts for city grids, then to 11,000 for local distribution, finally for your homes. Smaller transformers drop the voltage to around 230 or 240 volts. This system is beautifully designed, but also deeply vulnerable, because much of the world's grid infrastructure was built decades ago for a world that no longer exists. Modern grid faces many challenges never imagined by their designers. Unpredictable demand from electrical vehicles, distributed energy from rooftops and solar panels, and most of all, extreme weather. A single storm, a heat wave, a drought. Any of these can push aging grid past its breaking point. And what happens then? The consequences are not theoretical, they are deadly. In February 2001, Texas faced one of the worst power grid failures in US history. A brutal winter with a storm that swept across the state. The horrifying natural disaster resulted to gas pipelines frozen underground, power plants being shut down, millions of people lost power. Among them was an 11-year-old Christian Pavon. His family's small mobile home in Conroe, Texas lost heating during the blackout. That night, Christian went to sleep under a pile of blankets. By morning, he was gone. A victim of hypothermia in a modern American city, across Texas, at least 246 people died. From cold, from carbon monoxide poisoning, from power-dependent medical equipment failing. But while freezing temperature broke the Texas grid, on the other side of the country, heat and fire were threatening another. California's energy system faces a different crisis, driven by drought, high wind, and aging infrastructure. Between 2014 and 2017, PG&E reported over 1,500 fires sparked by its electrical equipment. In 2018, the Camp Fire devastated the town of Paradise, California. 85 people died, many unable to escape. It became the deadliest fire in California's history. Since then, California has adopted a difficult policy: proactive blackouts. Today, when conditions are dangerous, power is cut for millions of people, not because there isn't enough electricity, but because leaving it on could be even more deadly. But unfortunately, it's a grim reality of modern energy systems in a changing climate. California and Texas are far from alone. In South Africa, rolling blackout known as load shedding have become a routine. Hospitals have lost power to critical life support systems. Businesses survive on diesel generators. In 2023, a newborn baby died in a South African hospital when load shedding cut power to vital equipment. Other regions, including Pakistan, Lebanon, and parts of India, deal with chronic grid instability. For millions of people around the world, blackouts aren't a rare disaster, they're part of their daily lives. Not all power grids are created equally. Some countries have spent decades building some of the most advanced and resilient power systems on the planet. Others are still battling daily blackouts. According to the World Economic Forum's 2023 Energy Transition Index, Switzerland, Germany, and Singapore are consistently ranked among the highest in the world for energy security and infrastructure resilience, with grid reliability that's almost taken for granted in daily life. Switzerland has virtually eliminated major blackouts. Germany, despite transitioning aggressively to renewable energy, maintains one of Europe's most stable and advanced grids. And Singapore, operating in dense, highly urban environment, runs one of the most efficient energy systems through smart grid technology and infrastructure investment. But on the other end of the scale, the situation is very different. Data from the World Bank, the International Energy Agency, and Global News Report highlight countries like Pakistan, Lebanon, and Venezuela, where grid failure is a daily occurrence, not a rare event. In Pakistan, widespread rolling blackouts are common, with entire regions losing power for hours, sometimes days. In these regions, grid failure is a daily reality, not a rare event. In Lebanon, as reported by The Guardian in 2023, the state grid often provides just 1 or 2 hours of electricity per day in many areas, forcing millions of people to rely on private diesel generators just to survive. And in Venezuela, a country once rich in energy resources, chronic blackouts have affected nearly every major city, a crisis driven by decades of underinvestment and economic collapse. For some countries, electricity is invisible. For others, it's survival. And that contrast tells you everything about the future of energy. It's not about having power, it's about having a grid built to last. This story isn't just about failure. Across the world, engineers are building the grid of the future, smarter, decentralized, resilient. Smart grids use real-time sensors and automation to balance supply and demand in milliseconds, which is great, since we humans take an hour to choose a Netflix show. In Denmark, smart grids allow the country to generate over 50% of its electricity from wind, with some days exceeding 100%. Microgrids are small self-contained energy systems capable of operating independently during disasters. After the 2011 earthquake and tsunami in Japan, entire villages survived because of the isolated microgrid powered by solar and batteries. While everything else went dark, their lights stayed on. Massive battery farms and pumped hydro projects now store renewable energy for when production drops. California's Moss Landing facility can store 400 megawatts. Australia's Snowy 2.0 will add 2000 megawatts of storage. In Australia, nearly 1 in 3 homes are powered by rooftop solar, the highest rate in the world. Germany is targeting 80% renewable energy by 2030. This isn't just clean energy, it's energy independence. The power grid is being physically strengthened as we speak. Japan has buried thousands of kilometers of power lines underground. California is replacing the old-style wooden poles with steel and installing advanced fault detection systems. Global investment to strengthen the power grid is projected to exceed $300 billion by 2030. The power grid was one of humanity's greatest engineering achievements. But the world has changed, and we're entering a new era. An era where the future of energy isn't just about generation, it's about survival, flexibility, and millions of small energy sources, batteries, solar panels, microgrids, working together like the neurons of a living organism. So yeah, maybe it's time for an upgrade, because the 20th century called, and it wants its power grid back. Thank you for watching. If you have enjoyed this video, please make sure to like, comment, and subscribe. I will see you all in the next phase.